Imagine harnessing the power of an entire star, an unimaginable force that could propel a civilization into a realm of endless possibilities. Now let's shift this imagination into a concept that's both fascinating and audacious: the Dyson Sphere, or alternatively the Dyson Swarm. These are hypothetical megastructures, cosmic power stations if you will, envisioned to encapsulate a star, capturing its energy output and converting it into usable power. Imagine a shell or a swarm of satellites, each one soaking up the star's rays, transforming that raw celestial power into a source that sustains an advanced civilization. This cosmic leap isn't just a flight of fancy. It's a concept that finds its roots in the Kardashev scale, a method of measuring a civilization's level of technological advancement based on the amount of energy they are able to use. A Type 2 civilization, as this scale proposes, would be capable of harnessing the total energy output of its parent star. The idea of such a civilization and the concept of the Dyson Sphere itself sprouted from the brilliant mind of physicist Freeman Dyson. He pictured a future where our demand for energy would be so immense that we would need to tap into the stars to fuel our growth. This vision is both awe-inspiring and humbling. It forces us to question our own place in the grand cosmic scheme. Are we, the human race, capable of such a feat? Could we ever reach the status of a Type 2 civilization, bending the power of a star to our will? As we stand on the brink of our own technological advancements, one can't help but wonder how such a monumental endeavor might unfold. The first step towards building a Dyson Sphere or swarm requires a civilization advanced enough to venture deep into space. And that's no small feat. It requires technological advancements that at present seem almost unfathomable. Let's start with self-replicating robots. Why? Because these ingenious machines are key to the construction of such a massive structure. Imagine robots capable of replicating themselves using resources mined from asteroids and other celestial bodies. They would tirelessly build, repair, and even improve upon their design, continuously enhancing their efficiency. Speaking of mining asteroids, that's another crucial element. The materials required to build a Dyson Sphere or swarm are far beyond what's available on our home planet. But asteroids, those rocky remnants from the early solar system, they're treasure troves of resources. We're talking about iron, nickel, cobalt, and even precious metals like platinum and gold. It's an interstellar gold rush waiting to happen. But mining asteroids and self-replicating robots, while impressive, are just the tools. The real challenge is constructing megastructures in space. Picture this, a structure so large that it can encircle a star, capturing its energy output. That's not just building a house, it's more akin to constructing a planet. And we're not just talking about physical construction. There's the matter of maintaining gravitational balance, dealing with the intense heat of the star, and a myriad of other issues that need to be resolved. But all of these technological feats mean nothing without a unified and focused civilization. Building a Dyson Sphere or swarm is not a project for a single nation or even a planet. It's a project for a civilization. It requires the coordination and cooperation of countless individuals, all working towards a singular goal. The creation of a Dyson Sphere or swarm is not just a technological feat, but a testament to the unity and vision of an entire civilization. It's an audacious dream, a symbol of what we can achieve when we come together, and who knows, maybe one day that civilization will be us. Building a Dyson Sphere or swarm is not without its challenges, but an advanced civilization will find ways to overcome them. Let's begin with the obvious: the sheer scale of resources needed. The construction of a megastructure of this magnitude would require an astronomical amount of material. Not to mention, the technology to harness and manipulate such resources is currently beyond our grasp. But here's where asteroids could play a pivotal role. Picture this: an advanced civilization might develop the technology to mine asteroids, gaining access to vast quantities of metals and other resources. This could potentially provide the necessary materials without stripping their home planet bare. Next up, the time it would take to construct such a colossal structure. Given our current technology, it would be a project spanning millennia. But the concept of time for an advanced civilization could be radically different from ours. They might utilize time dilation effects, a concept straight from Einstein's theory of relativity. By traveling at near light speeds, time can effectively be slowed down for the builders, thus making the project feasible within their lifetime. Lastly, there's the danger of living so close to a star. The intense radiation and heat would be lethal to life as we know it. However, an advanced civilization might have developed shielding technologies beyond our wildest dreams. Imagine a shield capable of not only protecting life but also efficiently harnessing the star's energy. This would not only ensure the survival of the inhabitants but also provide them with an almost infinite power source. Every challenge we've discussed might seem insurmountable from our current standpoint. But remember, science and technology are always evolving. What seems impossible today could well become a reality tomorrow. As we venture forth into the cosmos, we'll inevitably face hurdles, but it's in overcoming these challenges that we'll push the boundaries of what's scientifically possible. With every challenge comes an opportunity for innovation, pushing the boundaries of what is scientifically possible. Imagine living in a world where energy is virtually limitless, a world inside a Dyson sphere or swarm. Bask in the hypothetical for a moment. A Dyson sphere or swarm, a megastructure completely encompassing a star, turning its every photon into usable energy. Now let's take a leap and envision life within such an engineering marvel. Picture the inside of this colossal construct where day and night are concepts of the past, and the star's energy is as omnipresent as the air we breathe. This limitless energy would fundamentally transform life as we know it. Imagine a society where energy scarcity is a forgotten notion. Every home, every device, every city would be powered unceasingly. The potential for advanced technologies is immense. With such an abundance of energy, we could power supercomputers that can simulate entire universes, or create technologies that can manipulate matter at the atomic level. But it doesn't stop there. With an endless power supply, we could potentially crack the codes of life itself. The biological processes that govern aging and disease could be understood and manipulated, leading us to the tantalizing prospect of immortality. Yes, you heard it right, immortality. No more aging, no more disease, just an endless expanse of time to explore, learn, and experience. This would be a world of perpetual progress where humanity is unshackled from its earthly limitations. We'd be free to explore the cosmos, to build, to innovate, and to dream without bounds. The barriers that once held us back would crumble, and the future would be a canvas upon which we could paint our wildest dreams. But it's not just about progress and exploration, it's about creating a society that's sustainable, harmonious, and equitable. A society that uses its boundless energy to ensure every individual has the means to thrive and contribute. Living in a Dyson sphere or swarm would redefine our understanding of existence, creating a utopia of limitless possibilities. As we look to the stars, we must ask ourselves, could we one day build our own Dyson sphere or swarm? This question may seem like the stuff of science fiction, yet it's a concept that's been gaining traction in scientific circles over the past few decades. In our current state, humanity falls under a Type 1 civilization on the Kardashev scale, harnessing and utilizing the energy of our home planet. Transitioning to a Type 2 civilization entails a quantum leap, where we would harness the total energy output of our sun. This is where the concept of Dyson spheres and swarms comes into play. But how far are we from this reality? Let's take a look at our current technological landscape. We're in an era where we've mastered nuclear fusion, dabbled in quantum computing, and made significant strides in space exploration. We have ongoing projects like the Breakthrough Starshot, aiming to send ultra-lightweight nanocrafts to our nearest star system, Alpha Centauri, which could serve as stepping stones towards a Type 2 civilization. Imagine for a moment a future where we've successfully built a Dyson sphere. Our civilization would have access to virtually unlimited energy, enough to power interstellar travel and sustain life indefinitely. We could create entirely new ecosystems within this superstructure, and perhaps even manipulate the very fabric of space and time. It's a future that's both exciting and daunting in equal measure. However, getting there will require a monumental effort, both in terms of resources and technology. We'll need to overcome numerous challenges, including how to gather and transport massive amounts of material in space, how to design and construct such a massive structure, and how to manage the vast amounts of energy it would produce. But if there's one thing history has shown us, it's that humanity has a knack for rising to the occasion. Given enough time, the right resources, and a collective will, we could well be on our way to becoming a Type 2 civilization. As we venture further into the cosmos, the question remains, what do you think of the possibility of Dyson spheres and swarms? Could this be the ultimate destiny of our civilization?